repetitive DNA now. So now we know what is this repetitive DNA, where is it located, how to isolate it first of all. Now again, within this repetitive DNA, which portion of the repetitive DNA is being used as probes? Let us talk about this. This repetitive DNA has been classified into different classes. We don't want to talk about all the classes, but what is the criteria for classification? It has been classified based on a criteria. So what is the criteria? The criteria is, number 1, base composition. Number 2, length of the repeat. Length of the repeating unit, whether it is 10 base pairs or 10-20 base pairs or whatever it is. Third one is number of times it is repeated. Okay, so this is the criteria based on which the repetitive DNA has been classified. So we have different classes of repetitive DNA, out of which we are making use of only the mini satellites. So actually in our textbook he told us that there are 2 types of satellite DNA. One is the mini satellite and the micro satellite. And the mini satellites. But then micro satellites are too small, so we are not using them in DNA fingerprinting. They are of a smaller size, less than 10 base pairs in length, whatever it is. So we are not using them for DNA fingerprinting. DNA fingerprinting. Whereas it is this mini satellite that we have been using for DNA fingerprinting. The mini satellites, the size ranges between anything between 100 base pairs to 20,000 base pairs. Okay, so this is useful for our technique. Okay, now let us talk about the mini satellites. Okay, I hope this is clear now. To understand the categorization, let us talk about one basic fragment. The base composition, how are they classified as? The mini satellites. Classified based on their base composition, length of repeating unit, and the number of times it is repeated. Okay, now when in terms of base composition, it is classified as either AT rich or GC rich. The length of the repeating units in terms of number of nucleotides. Number of nucleotides. The number of times it is repeated. This is highly variable. This is highly variable. Okay. Alright. So now let us, to understand this, let me take you an example and help you understand. Suppose we are talking about 2 humans, right? Human A and human B. In both the cases, we are working with chromosome number 1. Chromosome number 1. Here also we took the same chromosome number 1. And on this chromosome, a specific locus, let's say locus is L1. Here also pick the same locus as L1. Now, At this L1, we found that we have a repetitive sequence. That sequence is like A, T, T, A. Okay. Here also it is the same, A, T, T, A. So according to the criteria, it is a kind of AT rich sequence. Okay. We'll assume that yes, base composition wise it is AT rich. Now the second thing, how many times it is going to be repeated? How many times it is repeated? Well, this is where all the difference comes. So the length, what is the length of the repeat? The length is, it is 4 nucleotides long, right? The length is 4 nucleotides. Okay. Now what is the total number of repeats? That is important here. So we have 4 bases here, so we are talking it as one repeating unit length is 4 nucleotides. And the next thing we are going to discuss is about the number of repeats. In terms of number of repeats is what, as I told you, it is highly variable. Now let us take the sample or the chromosome 1. Okay, so this is the homologous pair we are taking at a time. Chromosome 1 of sample A, chromosome 1 of sample B. Okay, now the locus what we are talking about is L1. This is the L1 locus. Here also L1 locus. Now the repeat is AT. At L1 locus the repeat is ATTA, right? Yeah. How many times it is repeated? In this case it is repeated for 4 times. 4 number of repeats, 1, 2, 3, 4. And on the second homologous pair it is repeated for 5 times. So even in the same individual within the homologous pair, it is not going to be the same. It will be slightly different. So the number of times it is repeated is 4 times here and 5 times here. Clear? Now let us look into this. At L1, in this second case, the number of repeats are, here it is 8 times, and in the other case it is repeated for 5 times. 8 times and 5 times. Clear? So what is it you have understood is the number of times it is being repeated is something that makes the difference here. Now if it is repeated for 4 times, so a sequence of ATTA repeated for 4 times, 4 nucleotides repeated for 4 times. Total number of nucleotides, 4 fours are 16 nucleotides. The length of this repeat will be 16 here. The second case, 4 nucleotides that is being repeated for ATTA is repeated here for 5 times. So the now total length of the repeat would be 20 nucleotides, right? Now in the third case, as you can see, it is repeated for 8 times. So 4 nucleotides is repeated for 8 times. What are we calling this as? 8 fours. How much is 8 fours? Yes. Now the next one. 32 nucleotides here, and the next one is 4 nucleotides repeated for how many times? 5 times. 20 nucleotides. Right? Now you should know that the number of times it is repeated is different in each case, and as a result the length of the repeat or the length of the repetitive DNA at locus 1 is variable. This is something very, very important for us to understand the whole concept of DNA fingerprinting. Is this clear? Yes. So around the locus, now another important thing we should know is around each locus of repetitive DNA. Around each locus of repetitive DNA, we have a recognition sequence, recognition site. It has been part of evolution. This recognition sequence is on either side of the repeat. Either side of the repeat. This is conserved in terms of evolution. In terms of evolution, it is always the same, fixed. So here, as I told you, the number of repeats is what makes the difference between the length of the repetitive DNA at each locus. Now the recognition sequence, suppose this is your, so now I can take you to this and I can show that this is your recognition sequence on either side. Here is a recognition sequence. This is another sequence. So for this locus, you have the recognition sequence on either side, right? This is important here. Now, the VNTR, what is this variable number of tandem repeats? So it is this variability in the number of repeats which is otherwise called as VNTRs. VNTR stands for the variations or the variability of the repetitive sequence at a locus, that is referred to as variable number of tandem repeats. So the number of times it is repeated is variable? Yes, variable number of tandem repeats, one after the other. Now it is this VNTR that is forming the basis of DNA fingerprinting. So I hope this is clear.